Okay, and we're live. Okay, have you had a chance to even look at it yet to see like what the questions are? Basically, it's just a review of like all the terminology that we've gone over in the last few lessons. Oh dear. Sorry. So we're supposed to answer. Yeah, it starts out pretty simple. Then I'm like, I gotta go back and remember these terminologies. So the first thing is to distinguish between a categorical and a quantitative variable. So the categorical is, non-numerical is kind of how I think of it, and then the the quantitative is, attached to a number. You can quantify something. So I don't remember the definitions specifically, but that's how I think about it. See if they replied. No. And then the next one is distinguish between an observational study and an experiment. Oh, we need to go through the quiz here. Hello, hold on. I need to open up my quiz. So these questions are supposed to be the same ones that are on the group quiz. So if we just go through them all and do them all at the same time, then we should finish it up. So are you like, oh. Are you like like the desk person, the front desk person at the hotel or something, or the night auditor or something like that, since you work at night? Oh, okay. I thought of doing that. I thought of getting a job doing that because my day job is really intense, and I just think I'd not want some of this intensity. Oh, wow. I've got a crazy error. Are you able to log into the site? I don't know if you can if you're at work, but it is it is not letting me load. Okay, maybe it'll do it this time. Okay, this is looking better. I learned, yeah. Well, I was just trying to get into the BYU site, and it was some fail server error message. But we're in now. I'm in there, so it's fine. Okay, week 5 group quiz. We'll need the data set. Please remember to round to 3 decimal places. This helps when you take the quiz alone. Wait, you're supposed to do the quiz. So you're supposed to take the quiz yourself first? Wow, I didn't understand that the right way, I think. I don't know. I'm going to just do it this one, and hopefully it's fine, because I didn't know we were supposed to take the quiz. I thought we were just supposed to do the paper. So, okay, which of the following variables are categorical? The number of animals in the zoo, a randomly selected brand of toothpaste at a convenience store, the age and years of randomly selected vehicle in a parking lot. So the brand of toothpaste would be categorical because it's not. Yeah, that's what it's saying. Hey, Patrick.
Hey, how's it going?
Good. Did you take the quiz alone yet?
No.
So we just opened it up. Laura's here, and we just realized that we're supposed to take this alone before we take it as a group.
Oh, okay.
So since none of us did that, I don't know if we're going to lose points or what.
What is the purpose?
I'm not sure. I thought we were supposed to just do the paper and complete that and then come together to do the quiz. But when I opened the quiz, the first question says, I met with my group and completed this group quiz with them, and you mark it false when you take the quiz alone for the first time. So it looks like we're supposed to do it 2 times, but I didn't know that. So
It is due tonight, right?
it's due tonight. So, I mean, we could do it twice and mark the first time we're doing it alone, but we're kind of doing it together. So it's not, I don't know. I don't know if we're going to lose points for it, but I just misunderstood the whole direction. I thought it was, well, that's not what I thought it was.
Yeah.
So I'm just going to say true that I did it with the quiz, with the group, and I think we're going to be okay. Yeah, Laura, I think we'll be okay because I'm like, oh, I didn't anticipate that. So, Patrick, we're actually just on question 2. We just started with number 2 and shows that the are you opening the, do you have the quiz open, Patrick?
Yeah, I'm getting there right now.
Okay. So we're just identifying between categorical and quantitative variables. And the first one is, we think, toothpaste. That the toothpaste is the categorical variable versus the other 2 options, which are quantitative.
Oh, is this essentially a kind of a preparatory to the exam, it looks like then?
It is, yes, the exam review. Okay. Yeah, so the toothpaste would be categorical because it's not a number of something.
Mm-hmm.
Okay, so question 3. The mean IQ test score in the U.S. is 100. 20 randomly selected statistics students took an IQ test. The mean of their scores was 112. Which of the following statements is true? So 100 is a parameter, 112 is a parameter, 100 is a statistic, and 112 is a statistic. So the mean score is 100. 20 students took the test. The mean of their scores was 112. So the statistic is, yeah, 100 is the parameter, and then 112 is the statistic, right? Does it let you take both? Yes, it does.
Yeah.
Okay. All right. Rotham City has 4 neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One has low property, another has high property value. Property taxes are usually roughly proportional to the values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes? So we would want to get the cluster sample, right, where it's 1 from each section.
Yeah.
Stratified. Wait, which one's? But isn't stratified is one where you take one, like one of every 5th one, right? Or no, that's systematic. Sorry.
I think because there's the 4 different neighborhoods, you wouldn't want like a random or systematic, would you? You'd want, well, let's see here.
Okay, which one's stratified? I'll have to like look it up again to remember because I don't. Unless Laura, you want to explain it.
A sample that is drawn from a number of separate strata of the population rather than at random.
Oh, that's right. That's one that's based on like they're going to choose different okay, yeah, that'd be right. That's the right one.
Okay.
All right, number 5. When designed experiments are conducted in a public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students. The experiment is then conducted using all the students in the selected classes. That one's the cluster. No, that one's still the stratified. Hold on a second. Simple, voluntary, systematic, random, stratified, random. They randomly select the 4th grade students, and then they use all the students in the classes. Isn't that? Yeah.
Teachers.
So I think it's the cluster because they're taking the clusters of 4th graders
Randomly choose a particular district and randomly select.
Is it not stratted? That's what these two get me. I flip them. Because the stratified sample is where they select a specific group based on certain characteristics. But this one's random because they don't choose the fourth graders at first, but once they do, they only use the fourth graders. So is that cluster because of that?
They're randomly selecting the teachers, and then the students of the said teachers are the ones that are involved in the experiment. That's kind of weird. Because they randomly select the teachers.
But then they use all the students in each class for the teacher?
Well, from the sounds of it, it sounds like they use all the students within the teachers that they selected.
Yeah.
Randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all of the students in the selected classes. Which type of, I mean, is it just random? Because they're basically randomly selecting the teachers.
Well, I don't think so. I think it has to either be the cluster or stratified because they have specific characteristics.
Mm.
I'm bad about, once I think about it too much, I mess it up. Is it this one? I'm curious if it's this one. I think it was like lesson 2 where we talked about the types of random samplings. All right, I'm going to stick with cluster. That's what Laura said. I'm going to stick with it for now. We'll move on, and then I'm going to come back to it because I want to look it up. But we'll see what makes sense for the rest of these. So at a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? That's just a simple random.
Yeah.
Simple random, yep. Did I go too far? Nope, that's it. Okay. 7. A special interest group is conducting a survey regarding wolves in Yellowstone to adequately gauge opinions on both sides of this political spectrum. The researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100. Which type of sampling scheme? That's the stratified. Okay, yeah, see, that's the stratified, where they're choosing people based on a specific characteristic. Okay, a survey was taken of purchases at the crossroads. Open the data file and use this data to answer the next 3 questions. Using software, calculate the mean of the amount spent. Okay. So we have an Excel spreadsheet. Okay, so we need to know the amount, the average of the amount spent. So
amount spent of the entire column, I'm assuming.
I'm just going to do equals average next in the thing here and select it. And the average is 4.771 to 3 decimals. 4.771. Is that what you guys got?
Just about there. Yeah, 4.771.
All right, cool. Using software, calculate the standard deviation of the amount spent. So back to our spreadsheet. Equals STDV. Go. Whoa. $1.9007. 1.912 is what Laura got. What did I get? I don't even remember already.
0.9.
Oh, you know what? I did.
Did you use dev p?
I had it defaulted to the P, so I changed it to S. The stdev S. And that's 1.912.
Yep.
All right, and then start by creating a histogram of the amount spent in Crossroads purchases. Then mark the following statements as true or false. Did you actually create the histogram of the amount spent? So, I mean, the histogram is just a bar chart, right?
Of the amount spent. So can I just run a pivot table on it and say yes, I did it? See here.
I don't know. I don't do pivot tables. I do charts. Can you do a pivot table?
I don't know. Let's see.
I don't know. That's something I need to learn, and I haven't.
No, I think a plot chart would be good.
I just did a bar chart.
Yeah.
But then it's got all of them on there. That's not what I want it to do. I want it to combine. Oh, wait. So, oh, you can click histogram in Excel. So that's super easy. You go copy and paste the data into a new worksheet. The data analysis to say create histogram. Let's try that. So I have my data selected, and in the data tab, I want to create analysis. I don't have that data analysis tab. Data validation. I don't have a create histogram. Let's do it in here.
Where did you see that you could do that?
I was on like this. Looked it up on Microsoft support. Oh, okay. Here's this one. It's a clustered column. So you use it when the order categories is not okay. So if I do this, oh, whoa. Well, that's intriguing. Of course. What is this? That is, so it's basically just making a chart, but then it has to be the right data. So I don't want it to be like this. I don't like that. I don't like that at all. I mean, histogram is just a chart, right? Or is it a pivot?
Data, create a visual forecast worksheet.
There is a histogram tool in Excel. I wonder. It's in the analysis tool pack. These columns and the number that data is the data that you analyze by using the histogram tool. The numbers that represent the intervals that you want the histogram tool to use for measuring the data. Excel counts the number of data points in each data bin. A data point is included in a particular data bin if the number is greater than the lowest bound equal to a less than. But if you omit the bin range, Excel creates a set of evenly distributed bins between the minimum and max values of the data. And shows histogram table and helps show reflects data. For user, you have to make sure the analysis tool pack add-in is installed. Oh, okay. Do I have to do it this way, or is there like an easy way to just do a histogram? I don't remember this from the lessons. Did either of you remember from the lessons if there's some way to make a histogram without? Well, it says use the software, so If I go to options, add-ins, the analysis tool pack.
Oh, you have to have 2 columns of data to create a histogram. One for the data to analyze and one for the bin numbers. Okay. So what is the other data? So we've got the amount.
So
Is it the method? Is that the other thing that we want to do?
I am not sure. But I want to see if this will give me data analysis. I have it selected. Oh. Input range. I'm going to see if this does it. It contains information non-numeric. I change this to that and this. Will it do? No. So it can't have non-numeric data in it. So what? I'm busy.
The stuff that Cody put in his hair.
Yeah.
Like, can I do that?
No, you're not doing your hair purple tonight. No, go.
Not purple.
No, it's bedtime.
To make it lighter.
Oh, peroxide? No, not right now. We'll do that later. Go to bed. It's actually bedtime.
Okay.
Okay, so to do the histogram with the histogram tool in Excel, it can't have non-numeric values.
Well, all we have is numeric, or we only have one column of numeric values.
Right, so it would have to say, like, the method would have to be turned into values. Numeric values is what I'm thinking for this. I don't know because I haven't created it. But in essence, a histogram to my mind is just a chart where you're saying there's this many on credit, this many on cash, this many on iCard, right?
Mm-hmm.
So if we select both and just insert a regular bar chart, but we want to combine the values so it's not a whole bunch of them. Wait, what's this guy? Hold on. Oh, there's the histogram. Oh, gosh, that's even super dumb easy. Okay. So I highlighted the 2 columns. I highlighted both of them, and then I went to insert. And then under the charts section, there's the blue one that has a little drop down, and it's a histogram. Like, that's what it's called if you select it. I can share my screen.
I found it.
Okay, cool. Did you find it, Laura? Awesome. Okay. The only thing I'm not loving is that it's got these weird numbers on the bottom, which...
They're ranges of the dollar amounts.
Sorry, yeah, you got it, Patrick. They're ranges. It just took me a second to look at it. So is that... I don't even know what we're looking for now. I got all distracted trying to figure out how to make a histogram. Sure, I created a histogram representing the amount spent because it showed it by range of amount spent. this range, that range. I guess that's sufficient.
That was it.
Okay, I'm gonna say yes, I did that.
Mm-hmm.
Hopefully that works for the exam because I don't know. All right, so are we good to move on to 11?
Yep.
The team measured the body temperatures of a sample of diving elephant seals. The thermistor was placed at a specific location on each seal to measure the body temperature. The body temperature tends to decrease as they dive. They estimated the typical body temperature of each seal. At the time they initiated dive and called this the representative temperature. The thermistors were placed in the hepatic sinus of 4 of the seals. Okay, blah, blah, blah. The seal's body temperature at the start of the dive was calculated to be this. Complete the following table and use your work to answer the next 4 questions. Oh, okay. So the representative temperature, the deviation, and the square deviation. So we need to fill this in. If the representative temperature X is 37.91, the deviation from the mean is the representative temperature minus, wait, what is this A? Oh my gosh, I don't remember doing this. I mean, I remember doing this, but I don't remember what the A and the B stand for. What do the A and the B stand for?
Well, the A is just the question itself, question 11.
We're only filling in A and B.
What is the value of the number that goes in that position marked with the
Good
name?
golly, man, I am tired. Okay.
So what we need
What
is
is
X minus X with the line over it.
All right, so it's the representative temperature minus the mean, right?
Which was...
And the mean should be all 4 of those averaged out. Right? Am I?
Yeah.
Okay, cool. She's doing the same thing. So we're all on the same page. So the mean is 38.08. So the deviation from the mean is 37.91 minus negative 0.17. Is that what you guys have?
I'm still getting the darn average.
Yeah, that's what I got too, Laura. But I just rounded it up. Although, what are we supposed to round to? Oh, 3. So I don't need to round up. Okay.
38.075.
Yeah, that was the mean.
Okay. So we just subtract 37.91 by the mean, or vice versa?
You take 37.91 minus the 38.
Okay.
The mean. And then the other one is that squared.
So negative 0.165. Is that what you got?
That's what I got. And then you basically square it to get B. Oh, just kidding, because it's different numbers.
Different column, right?
Yeah, so we have to do 37.25 minus the mean of 38 point. Shoot, I didn't write down the mean. That was dumb. Did any of you write down the mean or remember? 38.075?
Yep.
Okay, so 37.25 minus 38.075 is negative 0.825, and then square that. 0.6806, so 0.681 is what I have. Okay, yeah, that's what I got, Laura, too.
How do I square it in Excel? I forget.
So I didn't use Excel. I just used my calculator. But you just times it by itself, so you could do that in Excel.
Gotcha.
And then
So what did you
I got 0.681. Well, 0.6806, which rounds to 0.681.
Okay.
Okay, we also need to get the standard deviation of these temperatures. So that'll be next. Okay, 13. What quantity is equal to the sum of the numbers in the squared deviations column? The quantity is equal to the sum of the numbers in square deviations. Isn't that the variance? None of them are correct? What is that? Is that called something though, Laura?
What quantity is equal to the sum of the numbers?
Is-
Sum of the numbers?
Is there a term for the quantity equal to the sum of the numbers in the square deviations column that's not one of those terms? I don't okay, see, I don't remember there being a name for it, but I forget lots of things. So, okay, so none of those are correct. It's not the mean. It's not the standard deviation. I wasn't sure if it was the variance, but I didn't think so because that's the, anyway, not that. Okay, number 14. What is the standard deviation of these temperatures? So I'm going to put those back into Excel real quick so I can just do a quick thing here. Whoops, 37.99 is out of the way. 37.25, 38.998, 38.16.
0.715.
Yes, what I got, 0.715. If you're rounding to 3. Where is it? Yeah. Yep, we all got the same thing. Cool. Under certain conditions, the standard deviation can be negative. That is false. The standard deviation cannot be negative. In the same study, the researchers placed thermistors in the 3 seals near their spinal cord and brain in the extradural vein. They placed thermistors in 6 other seals in their aorta, the largest artery. Finally, they placed in 4 other seals in their hepatic sinus. The results from the study are summarized in the, okay. It'd be cool if they just said, here's the results. This whole story. All right, which location resulted in the most consistent temperature measurements from one seal to another? So that'd be the one with the lowest standard deviation, right?
Yeah. So the middle one, the extradural.
Extradural. Yep, middle. Okay, we all agree. The number of hours students spent studying for an exam are recorded. The data are represented by the box plot. Use this box plot to answer the next 2 questions. All right. So the third quartile is that area from the middle to the top of the box itself, right? Let's see. It's first quartile, second quartile, third quartile. So 8. Finally an easy one, yeah. Okay, everybody understands that one? I don't want to, like, do we understand that one? Okay, cool. I don't want to just keep going. What percentage of the data lies between 4 hours and 8 hours? Note, list the number as a percent, not a decimal. Don't include the percent. Then, oh, okay. So if it's 66%, just do the 66. Okay, so between 4 and 8 hours, that's from the first, second, third. So it's 50%.
So just 50.
Yeah, just 50. Okay, following information to do the next 3 questions. All right, so it's going to use more than 2 standard. Okay, so it's unusual if it's more than 2 deviations from the mean. There are several contaminants in the water supply. Nitrates above 10 parts per million are considered a health risk for infants. Rexburg reports nitrate in the city's water is between 1.59 and 2.52, and values outside of this range are unusual. Okay, so we'll assume that mean minus 2 times the standard deviation equals 1.59, and shoot, is that what the population mean? That's the population mean, right? The U looking one.
So it's just giving you the equation of where they got the 1.59 and the 2.52.
So
it is reasonable to assume the measured nitrate concentration is normally distributed.
So if it's normally distributed, then for question 19, we're going to estimate the mean of the measured concentration in the drinking water. So we need to estimate the mean based on these factors. We know it's greater than, it's the mean minus 2 times the standard deviation equals 1.59, and mean plus 2 plus standard deviation equals 2.52. So using that information, we need to estimate the mean. So, how do I set this up? I want this. I'm going to write it down first, so I'm going to, whoa.
Are you almost done?
No, not yet. Sorry. You need to go lay down, Baba. Go change your clothes. You're in your thing.
I love how they say we're estimating the mean, but we're having to estimate 3 decimal places. That doesn't sound like an estimate.
Yeah, it's a pretty precise estimate. Okay, so how do we set that up? I'm going to look back at my stuff because I made notes at some point of this with our formulas. Also, we need to make our notes for the exam itself because we can have 1 page of notes for the exam. Oh, I have something. That's not it. I may not have it. That's the random variable. Rules of probability. Yeah, see, this is the, it's not, it might be these.
Mom, I'm watching you. I'm watching you right now.
Oh, are you?
On TV.
Okay, go lay down.
On YouTube.
Okay, go get your jammies on.
Again.
My kids get on YouTube and watch our live broadcast because I think it's awesome to watch it. Super exciting to watch statistics. Okay. So, yes,
Go grab that.
Isn't this the probability stuff? Isn't this where we went to the greater than 0 equal to with the z-scores and stuff? I'm trying to think if that's where we're at. Oh! This is 6890. Whatever it's called, rule. Here. Oh, pushy buttons. Shoot. This one. Observation. Oh, okay, wait. Above 10 parts per million. That's a health risk. Wait, does that matter to this?
I don't think it has anything to do with this.
Yeah. We will assume is the value. Okay, 1 point. Measured nitric is normally uses information enter. So if it's normally distributed, we have the means minus 2 times standard deviation. We don't know. But we don't know if it's. You're beyond lost, Laura. You're lost. You can't be lost. I count on you to know what the heck you're doing.
Same darn equation. One's just adding and one's subtracting.
Yeah, so you like it's the deviation. I mean the standard deviation. I think it has to do with the two standard deviations away from the mean. So if you take -2, this is like the applet or something. Like it's between 1.59 and 2.52. So it's between those two parameters.
Okay.
So the mean is -2 times the standard deviation, and that's the lower part. And the mean plus 2 times standard deviation is the higher part. So I'm like trying to visualize this. So I'm thinking this is going to be lesson 3 because we just did the stuff that was in lesson 2. So I'm going to see what I can see in week 3 if it explains this because I am not remembering. But see, question 22 says, between what two measured concentrations do approximately 68% of the data values lie? Which makes me think this is part of one of the 6890. I can't remember what the rule is. 6899. See, I forget. You guys remember what it's called? That rule. Isn't there a place just to see all the textbook in one spot? I guess they all can, actually, can't they? Because you just go open the book and you can select any chapter. Yeah. Okay, the rules of probability. Is that what we're doing? What percentage of the data? Wait. Estimate the mean.
Those two numbers, that's the standard deviation, right? Between the two?
Well, I'm not sure. I'm not helpful on this one because I can't figure it out. Because the standard deviation is like if it's more than 2 away from the mean, it's unusual. But it's saying it's not unusual.
Pittsburgh reports nitrate concentration in the city's drinking water supply is between 1.59 and 2.52. So that's the range, right? So is it something as simple as we want halfway between those two? Is that the mean?
Well, I think so. It's the average between them, but I'm not sure how we're going to find it. I know this is a simple thing.
Well, I'm sure that this is probably not the exact formula or whatever, but I mean, isn't it as simple as taking 2.52 and subtracting 1.59. That gives us the difference between the two, which is 0.93. And then I guess halfway between those two would be half of that. Does that make sense? And it's not the way that they probably want us doing it.
Yeah. How do they?
We'll get 2.055.
No, not alternative cost. The mean cost is equal to this. The mean cost is simple for the population mean. So yeah, that U is the population mean. We could rewrite the null and alternative hypothesis more simply. The p-value is a probability that the data would be extreme or more extremely observed. Based, okay, that's not what I want. You take one benefit is that you can visualize the distribution. A histogram illustrates the overall shape. But we don't care about that because we know it's normally distributed, so that's not even part of this question. Center of distribution. Oh, no? Is that what this is? The sample mean or sample is the most common tool to estimate the center of distribution. It's referred to simply as the mean. It's adding up the observed data and dividing by the number of observations in the data set is very important ideas are a symbol. The sample mean has both a name and a symbol. You may have heard of for average users. Mean, median, what are all examples. The word average will be used to describe the mean. Okay, median is the middle value, right? Mode is most commonly occurring, blah, blah, blah. We only have data on the cost to treat. Sample obtained depends on random chance. The setting is repeated if we draw perspectives. The shape of the standard deviation and variance. These seals have those. Hey, they just did the thermistor thing that we already did. In this section, later, mean mass of the seals. No, this is measured as the center. The seal has a mass. The standard deviation is a measure of the spread. If it's small, they tend to be close together. Standard deviations are the tend to be spread out. Standard deviation is also the same as standard. We're working with symbol to be explicit. Symbol for the standard deviation is S. O. Sigma. The parameter representing the population standard deviation is sigma. I'll call it sigma because that's what it, whatever. In practice, we rarely know the value of the population standard deviation, so we use a sample standard deviation as an approximation of the unknown population standard deviation. Sigma, you don't know how much. If we use, okay. What I need to know is if two variables are measured on the same scale, variables with values that are further apart will have the larger standard deviation. So the mean mass of the men was mean equals 80. The standard deviation was S. See, we don't know that. We're supposed to estimate the mean. The size of the mode. Those are spread out masses of men. But we don't know the standard deviation, and we don't know the mean. We're supposed to find that based on this information. Like there's a few things. There's sphere. The other point is I draw a vertical and we now draw these horizontal lines. deviation equals the value minus the mean, deviation equals the value minus the mean. If the observed value is greater than the mean, deviation is positive, deviation is negative. Please participate. Your answers. Okay, that's doing the standard deviation by hand, but second column.
I mean, is it really as simple as just the basic formula of a mean, taking their two numbers and dividing it by 2?
I don't know. So you mean 2.52 divided by 2?
No.
Is that what you're saying?
Well, kind of. So it would be 2.52. You add 1.59 and 2.52 and then divide by 2 because they're two numbers.
I don't know.
2.52. Okay, 1.59. 2.52. You add them together. And divide by 2. It gives us, which is actually the number that I got previously, 2.055. That's halfway between the 2 points. I think that's the answer.
That'd be the median though, right?
It's the mean in this case, because we're only given the two variables. So you add those two variables and divide by 2 because there's only 2, and that's the mean between those two numbers.
Yeah. Sure, we can do that. I don't even know. Like this whole problem has got me.
I think we're getting thrown off by the formulas that they're giving to us. I don't think we necessarily need them for this question. All we need is the 1.59 and the 2.52.
So
I could be wrong.
Divided by 2. Is that what you're saying? 2.055?
Yeah.
Is the value of...
That's exactly in between those two numbers.
Estimate the mean of the measured nitrate. But then how do we estimate the standard deviation?
Well, the standard deviation is just the difference between those two numbers, right?
Yeah.
So that's just the 252 subtract 159, which is 0.93. But I'm gonna look up in the text here and see what it says.
Yeah. Oh, let's see if this one gives me. Without making me pay. Is 2.055.
deviation is
You're right.
standard deviation is a measure of the spread in the distribution.
Oh man, I just have to make things more complicated. Sorry. It's
Yeah.
terrible.
That's what it is, right?
Okay, but the standard deviation is something different. How did they get to that? They're getting, okay, wait, to determine the standard deviation though, you do the, that was this one. This one 3. There was the whole how to do a standard deviation by hand, which I think we can do. This, shoot, where'd it go? Roll down, center. Okay, standard deviations by hand. The mean is a measure of the center. There's a fairly large difference in the mass of the system. Okay. It's a measure of the spread. It is standard issue. Okay, yeah. We're working to be explicit. Sample. So the sample, we don't know the sample standard deviation. Oh, I'll just stick it in Excel and see what it tells me. The 2.52 and 1.59, right?
0.93.
Oops. .657 .658. That is not what they're getting over here. Are they getting that number? If there's two, how do we get that? No. How do I solve this?
Calculate standard deviation of those numbers, work out the mean.
Did you watch the video, like the exam thing?
I did, but I didn't see them do this. It was actually not that great, in my opinion.
Oh, darn it.
I mean, it was in some cases. And for each number, subtract the mean, and square the result, then work out the mean of those squared differences. Take the square root of that. You're done.
So if it's 2 standard deviations away from, okay, that has to be 2.20. Values outside of this range are unusual. How to solve? Okay, I'm looking up some examples online of like statistics problems that have this similar question to see how they are solving it. But this is probability. Subtract the larger probability from the smaller probability. And that's the normal distribution probability. I don't need that. I need the... $1.59. So this is a... This 1.59 is minus, and then this is 2.52. I know I'm making this more complicated than it is. It has to be like an easy thing, and I, for the life of me, cannot think of what they're doing here. But with this question too is throwing me into thinking it has to do with the and how do we get so the sample mean is what did we say, 2.055? That's the sample mean.
Yeah.
And to get the standard deviation, we take the sample mean by making, we take the sample mean and subtract the mean from each. Standard deviation is the square root of the variance. One is really down. Standard deviation is sigma equals square root of sigma squared, which we don't know. Wait a minute. If it's That's just 2. Whoa. No. I am totally stumped. I won't lie. I am stumped on this one.
Want to move on?
Yeah, let's keep going. So, I mean, like, if we get that wrong, we get it wrong, and we'll come back to it or something. I just don't even know how. Oh. So, between what 2 measured nitrate concentrations do approximately 68% of the data values lie?
This is the 68 whatever rule, right?
All right, Laura, we still haven't figured out how to answer the question 20, so we're moving on to 21. So 68% is going to lie in above the mean. So it's 2.055 and 2.52, right? Because it has to be above.
The mean was 2.055. You said 68% is above. Okay.
Is that right, though, or is that going to be larger than the mean? It'll be less than the mean and greater than the mean.
Looking at that rule here. 68%.
Because the whole parameter is 1.59 to 2.52. So it's not that one because that's 100% of them.
So 68% of the data will lie within 1 standard deviation of the mean. 95% of the data will lie within 2 standard deviations of the mean. 99% of the data will lie within 3 deviations of the mean. Let's see, how do we...
So is it D? It's within 1 standard deviation of the mean? Oh, Laura left again. No, dog.
I think it's D. Because that would be out of all of those, that would be the example that's 1 deviation compared to the other.
That's what I think. I think it's D for the same. Yeah.
All right. The admissions committee for most Master's in Business Administration programs require the Graduate Management Admission Test, GMAT. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted.
Okay, so we have to do The probability.
Randomly selected student will score above 542.3.
Yeah. So this is where we were doing that one calculation for the probability.
Mm-hmm.
Don't we use the applet for this one? Because we need to find the z-score and then put it into the probability applet
Mm-hmm.
and then determine the probability. So the z-score is the mean minus the standard deviation, right? No. It's the oh shoot. I know this one. I start forgetting when I'm tired. Gets worse when I'm tired, rather. Z equal, oh, of course I didn't write the actual formula. I just wrote the question at that time. This is like,
So we're 542.3.
where's my applet?
Is it minus 500?
Okay, so it's the value minus the population mean. Yeah.
And then what do we do again?
Value minus the mean over the standard deviation.
Gotcha.
Sigma. Okay, so our question goes back to the value. Okay, so the standard deviation is 120.54. Top of that, the mean is 542.3. The value is is it 500? The minimum score is 500.
So I have a z-score of 0.351.
Did you do your value as 500? I didn't.
Yeah.
Oh, okay. Negative 0.351. I mean, it goes both ways, so it's fine. But
Yeah.
okay, so my applet. Oops, z-score. So the probability of which one? Oh, no. Oh.
Probability that they're going to get higher than that, right? What is the probability the random selected student will score above that?
So it's actually.
I have 36%.
We totally did this on another exam. I don't remember which quiz, but we did this like exact same question, and I don't remember which we, because it threw us off. We were saying, wait, zero, because it was the mean minus the mean over the standard deviation. You can't have 0 divided by. You can't use 0 on top, but that's what it would be because we're trying to determine what's over the mean. And I don't remember how we did it.
Well, in this case, we're taking the 542.3 minus 500, right? And then dividing that by 120.54.
Well, we're supposed to take the value of 542.3 and divide and minus the mean from that, but that is the mean, so that's that how we did it before? My gosh, I'm like so tired I can taste it. This is so silly. Okay. Where did I do that one? My gosh, I don't remember. Wait a minute. If the mean is, it'll score above 542.3. Is it just 50%? Because if we do 542.3 minus 500, is that the 0.351?
Yeah, but now you have me questioning it.
Because if the
Well, and that would be the z-score, and then if you put that into the applet, then it brings you a probability of 36%, 0.3628, so 0.363. Probably what I'm going to put, but I'm not overly confident.
because we're having to find out the mean minus the mean. How did we do this? Darn it. 120. You can't do 0 divided by. How do I solve? For how to standardize a mean and standard deviation based on the. So a z-score of 1 is 1 standard deviation above the mean. Like, I feel like it's, oh, we totally know this. We've done this. This is so silly. A number.
I think we already had it. I think that you take the z-score that we had and put it in the applet, and that gave us a probability of 0.363.
I don't remember how we calculated this. So I found the answer to this problem and we're not getting it. But I want to figure out how they got it.
This exact question.
Yeah. I just looked up the question. I
What's the answer?
It's 0.5. Let me see if I can figure. Let's see if we can figure out the next one, and because this whole
the exact same question essentially.
Right, but it's got a different number, and I feel like if I could figure out the right way to do it that way, I might get my brain around the other one, because this one has a different value. It's 600 minus the mean over the standard deviation, which makes sense to me. Let's see what this comes out to. Oops. That z-score minus 542.3 equals 37 divided by 120.54. Because this is z-score of 0.4786 to 0.479. And if I put that in the applet, the areas, 0.6327. See, that's not what they're telling me in this thing either. Wait, it's to score below. That was my problem. There it is. Now I have it right. Okay. Point. So I got it right with the 600 because that one makes sense to me. We have a value minus the mean over the standard deviation. What's throwing me off is that we're having the mean minus the mean, and you can't do that because it's 0. So I'm missing something. Is it just? Is it? It would help if I could type.
So with the other one, you did 600 minus what?
Oh, sorry. I did 600 minus 542.3 over 120.54. And then I put that into the applet, the z-score. And the z-score came out to 0.479. Well, 0.4789. And then I highlighted the areas below the z-score, the positive z-score, because we want to find out what'll be below the 600. And it's 0.684. How many decimals we're rounding to on this one? Low is 0.684. Score. Okay, and then to do above 600, it'd be the 2 points. .316 to see how much would be above the z-score. I mean, the 600.
Mm-hmm.
But how do I calculate this properly to be how much is above the mean? I mean, I get that the answer's there, but I feel like it's cheating to just plug in an answer if I don't know how I got there. So I don't like doing that. So I'm sorry. That's why I'm hung up on this.
No, you're fine.
Like, I don't mind having help to, like, but I don't want to put something in I can't figure out how it got there.
So we're 23. I vaguely remember that we had this exact question, and
We did.
It seems like we wrote down the same answer for 23 and 24, and that isn't correct.
Right. Well, that's because we didn't move our distribution area on the applet. So the probability for a student scoring below 600 is anything below the positive z-score, or I mean to the left of the positive z-score. So you turn those areas blue, and that's 0.684. And then to find the opposite, you highlight the remaining white area, only the area to the right of the positive z-score, and it's 0.316. And that's the probability of scoring higher than 600.
And then the other one is what, 0.684?
Yeah, so it's 0.684 for 23 and 0.316 for 24. But this whole mean thing, is it always going to be 50% to have a probability of getting above the mean? Is that like a thing that I'm just not remembering?
because it's exactly in the center. But
Yeah, even
for the standard deviation, though.
right. See,
That is what the standard deviation is.
standard deviation is
Let's see here.
standard deviation of 120.54. The minimum GMAT score required for the admission is 500. So what's the probability that it will score above average, the mean? That's why can't I figure out what that? All right, I'm gonna have to go. Let's keep on going because we're gonna run out of time and I'm gonna get frustrated. Do our best, and I will have to come back and study those things because I know it's in there because we've done this exact same problem on other quizzes. Find the GMAT score that corresponds to the 10th percentile. So if we're calculating percentiles, it's a number such that a specified percentage of the data is at or below this number. So we want at or below 10%. Actually, the 10th percentile, yeah, that'd be 10%. So we can find the values using the applet to calculate the z-score. We need a z-score that corresponds to the percentile.
Can we just put in 0.10 into the area?
Oh, this is when we put the desired percent in the area.
Area, yeah.
And it gives us the z-scores.
Yeah.
Did you already know that? And I just hadn't remembered. I had looked up.
Well, that was what I was just coming up with. So we put the basically 0.10 in there because we're looking for the 10th percentile.
Yes. Mine doesn't want to do this. 0.10.
But that gives us a z-score. It doesn't give us the GMAT score, right?
Mine's going to 0. Is yours working?
Yeah.
What the world? I take this out. Take you out. No, take. Oh my goodness. Delete all of you. It won't delete everything. Oh, now it did it. Oh, weird. Okay. 1.282 is the z-score, right?
Yeah.
Okay. So to get the percentile, type in a number would be, yeah, okay. The z-score will, for example, we'll find the z-score. So how do we find the average that corresponds to the percentile? Okay, what is our question though? Do we need the?
We need the GMAT score.
Okay, so we need to solve for x in the equation for the z-score. We know the z-score. We need to solve for the value. So the z-score is 1.282 equals x minus 542.3, because we know that, over the distribution, I mean deviation 120.54. Then we solve for x. So we have 1.282 times 120.54 is 154.532 equals x minus 542.3 plus 542.3, 696.83 equals x. That is a really high score. Could that be right?
What What was the
Actually, it's
number you
not
got?
that high. If they don't take anything else than 600. What?
What was the number you got?
I got 696.83.
for
Which
10
is wrong
else?
because I have the answer. And that's terrible. I shouldn't know that, but that's what it is. Oh, I got the answer. I got the answer for the 90th percentile. So I did it wrong. Oh, no, that wouldn't affect it. Would it? If the, let me look at my applet here. Oh, well, it'd be, how is that going to change it? It would change this part, but I don't think it would change. What did you get?
I didn't.
Didn't get.
Let me plug it in here.
If I take this out and I say, yeah, it's just negative. Oh, it does make a difference. It'd be 387.76, so it's equals X. Okay, so I didn't have the right, I had positive negative flipped around because the 10th percentile is going to be on the lower end. It'll have the negative z-score, whereas the 90th percentile is going to have the positive z-score. And I did it positive. That was totally my fault there. So for rounding to the nearest whole number, the 10th percentile is going to be 387 round with that 7, so 388. And then the 90th percentile will be 697. Okay, that makes sense. I can get behind that. If I would just put the right thing.
0.697. Oh
No,
that's
it's a whole number. It's just 697.
And what
Yeah.
was the 10%?
It was 388.
My phone's gonna die here in a second, so.
Oh no, are you on your phone? Sorry. Okay. How many more questions? We have like 4 more questions. Okay, let's knock them out. Find the first quartile of the distribution of GMAT scores. So the first quartile would be 25%. So we do the same thing, but do 0.225. So our z-scores, right? Negative 0.674 equals x minus 542.3 over 120.54. Come here. Okay, so we have negative 0.674 times 120.54. Negative 81.24 equals x minus 542.3 plus 542.3. This is 461.05 equals x. So 461 when rounded to the nearest whole number. 461 would be the first quartile. Okay, the third quartile would be 75%. So change this to 75, and that's going to be on the higher side. Nope, 0.75. Oh yeah, that's going to be over the 25. Okay, so then the z-score is positive 0.674 equals x minus 542.3 over 120.54. And if I do the math, 0.674 times 120.54 equals 81.24 equals x minus 542.3 plus 542.3. So it's 623.54 equals x. Round that to the nearest whole number at 624 for the third quartile. Okay. Those make sense. Okay, simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of sample mean scores for all such samples? The mean of the distribution of sample means is going to be the same as the population mean. So it's 542.3, right? Because the sample mean is equal to the population mean. And then what is the standard deviation of the distribution of sample mean scores for all such samples? So the standard deviation of the sample mean is that calculation. Okay. Standard deviation of the sample is, where was that calculation? That's the, this is where we do the standard deviation over the square root of the sample. So if n is 15, so it's the standard deviation, which is, so it's 120.54 over the square root of 15. So 15 square root is 3.872. 120.54. Okay, so 120.54 divided by 3.872. That's not the standard deviation. That can't be right. No. Oh, it is 31.13. One, two, three. Thirty-one point. So yeah, the distribution of sample mean scores for all such samples. What is the probability that the sample mean score for a full random sample of any greater than 600? Okay, to do this one, I have to do the probability, the sample mean. Okay, what's the probability? Over not right. This one is in less than 7. The mean of the random variable, the standard deviation of the random variable is Oh. Wait, so if I know my z-score, the z-score for 600, the z-score for 600 0.479. So 0.631. So it's 1 minus 0.631. 1 minus 0.631 equals 0.369. Will be above 600. What's the question? And one minus 0.3160. 1 minus 0.3160. 0.684. No, that doesn't make sense. That's 68% are going to be. What is the probability? So we have the value 600 minus, oh, it's divided by 120.54 divided by the square root of 15. So, okay, there we go. Then I have 600 minus 542.3. Okay. 15 square root is 3.8729. So I have 120.54 divided by 3.873 equals 31.123 under 600 minus 542.3, 57.7 divided by 31.123 equals 1.8539. That is the z-score. And then I throw that in the applet, and my z-score is 1.8539. Ha! So my probability equals 0.0319. Got it. Anything else today? Because, okay, good. Oh, case study instructions.
Credit card, so they can't add it on the slip. And they're like, oh, hey, do you have a PayPal account? I'll totally give you your PayPal account. I would be like, heck yes, here's my information. So, I mean, it's definitely worth it a shot. You ask. But it's not guaranteed that anyone would have those accounts to receive funds that way.